Okay, so today we're going to be practicing the first derivative test. Okay, so for the following functions, use the first derivative test to determine if the critical points are maximums, minimums, or neither. So when we're finding these relative maximums, minimums, we first have to find critical points. So basically we're using a skill that we've already learned. Critical points come from the zeros of our derivative. So the first thing you need to do is find the derivative, f prime of x, which is 3x squared minus 12x. And then we set it equal to 0. Okay? Well, to find zeros, you got to factor. So we factor this as 3x times x minus 4 equal to 0, which means our critical points are at 0 and 4. Okay? Now we're going to set up our derivative test. So we're going to put 0 is 0 and 4 is a 0. So there's the zeros of my first derivative. Next, we're going to test it, which means we're going to pick points like on this side, like -1. We're going to plug it into our first derivative because that's what we're testing. We're going to test our first derivative, see if our derivative there is positive or negative. If the derivative is positive, that means my function is increasing. If it's negative, it means my function is decreasing. So when I plug -1 in, I get a negative times a negative here, which is positive. When I plug in +1, I get a positive times a negative, which is negative. On this side, I plug in 5, which is positive, and positive, which is positive. Which means this point right here, this is a critical point, and on this side my function's increasing, on this side it's decreasing. Since it goes from increasing to decreasing, this is a maximum, and this one, it goes from decreasing to increasing, which means this critical point is a minimum. Okay? Now, the second one, same process. So the first thing you do is find the derivative, so we can find our critical points. So find the derivative, which is 12 minus 3x squared. Set it equal to 0. Factor. So we take out our greatest common factor, which is 3, so we get 4 minus x squared. And then 4 minus x squared, set that equal to 0. So you get 4 equals x squared, so x equals plus or minus 2. So our number line, -2, +2, those are our critical points. Plug in -3. When you plug in -3, -3 squared is 9, so 4 minus 9, that's negative. So on this side, it's negative. Then you plug in 0. 0, you get positive 12. And then when we plug in positive 3, we get negative again. Okay? Which means this point, my function is decreasing and then to increasing because it's negative to positive. So negative slope here, positive slope there. So this one is a minimum. And this one goes from positive to negative, which means this is a maximum at 2. Okay, the third one. Now, the derivative for this one, we've got product rule, and we have chain rule. Okay? So, derivative of x is 1. This times the square root of 16 minus x squared, plus x times the derivative of this. I'm going to use this equation. D over dx square root of u is equal to du over 2 square root of u. So that's the formula I'm going to use for this next derivative here, for this one. Which means that I'm going to get 2 square root of 16 minus x squared on the bottom. And on top is the derivative of this, which is negative 2x. Okay. Now, I need to get common denominators here. This 2 divides out with that 2. So I'm going to multiply this, the top and the bottom, by the square root of 16 minus x squared. 16 minus x squared. So I can get common denominators. So on the top, I get 16 minus x squared over the square root of 16 minus x squared, minus, because there's that negative there, x squared over the square root of 16 minus x squared. And when we simplify, we get 16 minus 2x squared all over the square root of 16 minus x squared. Now, our critical points. So we set this equal to 0. So over here, we're going to have 16 minus 2x squared minus 2x squared equal to 0. So this is going to be x equals plus or minus the square root of 8. But we also have to deal with the bottom being undefined because our critical points come from there as well. So we also have to set 16 minus x squared equal to 0, the denominator. Okay? So when we set the denominator, we also get x equals plus or minus 4. So this one has a lot of critical points to check. So we have negative 4, positive 4. Those are our undefined points. So that's why I'm putting a u there. Now the square root of 8, that's in between 2 and 3. So let's put the negative square root of 8 here and the positive root 8 here. Those are our zeros. So now, the bottom. Okay, so can we put negative 4, anything on the left side of negative 4? Like negative 5. If we put negative 5 here into our first derivative, you're going to get on the bottom 16 minus 25, a negative. So remember, that makes it imaginary. So there are no solutions here. So we don't have to even worry about this side and that side. Okay? Can't find those. Because if you plug them into your first derivative test, it's not going to work because you can get negative numbers on the bottom. So we pick negative 3 right here. When we plug in negative 3, positive on the bottom, when we plug in negative 3 on top, you're going to get x squared. So that's going to be 9. And 2 times 9 is 18, so negative here. Then we're going to plug in 0. When we plug in 0, we get a positive divided by a positive, so this is positive. And same thing when I put in positive 3. Bottom's positive, and the top's going to be negative. So for this function, here, it goes from decreasing to increasing. So this is a minimum. And this one, critical point, goes from increasing to decreasing. So this is a maximum. And then our last problem, again, find the derivative. So this is h of x. I don't know why I was about to write f. So our derivative, h prime of x, we have to do quotient rule. So it's low, x minus 5, times the derivative of the top, which is 1, minus the top, times the derivative of the bottom, which is 1, all over x minus 5 squared. Okay, and then when we simplify, we get x minus 5 minus x over x minus 5 squared. which gives us negative 5 over x minus 5 squared. We set that equal to 0, and our critical points, since we don't have any x's in the numerator, I don't have any zeros, but on the bottom I have one critical point, x equals 5, and that's where my function is undefined. So that's all we got. So we put 5 here. Okay, that's where my function is undefined. Plug in negative 6. When we plug in negative 6, we're going to get a negative divided by a positive, because the bottom's always positive, the top is always negative. And when I put in 10, I still get a negative. So this function has no relative maximums or minimums. Okay.